The greenhouse effect is the primordial sacrament of modern climate science. It is preached from kindergarten to the nursing home. The simple name of this effect and its ubiquity in culture and mainstream media leave no doubt that we are dealing here with solid and fully understood natural science. But how does this effect work? How is this effect derived from basic physical principles? How can the effect be measured? These simple questions should be clear and easy to answer. I must disappoint the audience. The atmospheric greenhouse effect is and remains a mystery. In 1995, the German Meteorological Society opens a statement in which, referring to the IPCC's argumentation, it assures the public that the greenhouse effect really exists with the sentence:
Es ist unstrittig, dass der atmosphärische Treibhauseffekt noch nicht unzweifelhaft nachgewiesen werden konnte.
It is indisputable that the anthropogenic greenhouse effect has not yet been proven beyond doubt. This is astonishing. A branch of science sponsored with many billions of taxpayers' money is not able to trace its basic premise back to fundamental physical principles or even to measure them. In climate science, there are many explanations for the atmospheric greenhouse effect, some of which are contradictory. A good overview of these explanations can be found in a publication of Jurlick and Teuchner, Falsification of the Atmospheric CO2 Greenhouse Effects Within the Frame of Physics. The fact that the atmospheric greenhouse effect is nowhere properly explained and that there is no measurement specification for the effect does not stop modern climate science from telling us that the atmospheric greenhouse effect is warming our world by 33 degrees centigrade. If we want to know what the atmospheric greenhouse effect is all about, we have no choice but to look at how the IPCC arrives at the much-cited 33 degrees centigrade greenhouse effect. The basic idea behind this calculation is simple. The greenhouse effect is the difference between the average temperature of the Earth measured via weather stations and the temperature that the Earth should have without the effect of the atmosphere. The temperature of an Earth without an atmosphere is calculated using the Stephen-Boltzmann law. The Stephen-Boltzmann law states that the power of thermal radiation emitted by a solid equals its surface area, A, times the Stephen-Boltzmann constant A, sigma, times the difference between its surface temperature, T, to the fourth power and its environment temperature, Tu, to the fourth power. The Stephen-Boltzmann law is applicable to so-called black bodies in thermal equilibrium only. A black body is a solid that absorbs all incoming radiation. That means it has no reflectivity. In thermal equilibrium means that it has the same temperature all over its surface and it absorbs as much radiation from its environment as it emits. Since the Earth radiates into 0 Kelvin cold space, the Stephen-Boltzmann law simplifies to the radiated power, P, equals the surface area, A, times the Stephen-Boltzmann constant, sigma, times the surface temperature, T to the fourth power. Or resolved for the surface temperature, T equals the fourth square root of P, over, A, sigma. The Earth is not a black body. According to satellite measurements, it reflects about 1/3 of the incoming radiation back into space. This reflectivity is called albedo. The formal symbol for the albedo is alpha. For the Earth, the albedo is about 0.3. To correct for the reflectivity of the Earth, a correction factor of 1 minus alpha is introduced into the Stephen-Boltzmann law. When we calculate a planet's surface temperature via the Stephen-Boltzmann law, we assume that the planet's surface is heated exclusively by the absorbed radiation. The absorbed radiation energy is converted into heat and then radiated back into space as thermal radiation. After a heating up phase, the planet's surface irradiates as much energy per unit of time in form of thermal radiation as it absorbs in the same unit of time from the incoming radiation. In this state of equilibrium, we can state the power of the absorbed radiation equals the power of the emitted thermal radiation. P, absorbed equals P, emitted equals 1 minus alpha, times the surface area, A, times the Boltzmann constant, sigma, times the surface temperature, T to the fourth power. The power radiated by the Sun onto the Earth is quite constant. It is the so-called solar constant S0. It has a value of 1367 watt per square meter. This value was determined by satellite measurements. For the following calculations, it is assumed that the Earth is hit by solar radiation that passes vertically through a circular area with the radius of the Earth's sphere. 1367 watt of radiation pass through each square meter of this area. Now that we are equipped with a suitable formula and the radiation power that hits the Earth, we will try to understand how the 33 degrees Celsius greenhouse effect is calculated. In the fourth assessment report, Climate Change 2007, the Physical Science Basis Chapter 1, Historical Overview of Climate Change Science, Page 97. There is, so to speak, in a subordinate clause, a reference to how the IPCC determines the greenhouse effect. It is assumed that the Earth receives about 240 watt per square meter of radiation from the Sun. This radiation is absorbed, warms the Earth and is then re-emitted from the Earth into space as infrared radiation. With these 240 watt per square meter, one goes into the Stefan-Boltzmann law and calculates the temperature that the Earth should have without the atmosphere, and thus without the atmospheric greenhouse effect. The result is minus 19 degrees Celsius for an Earth without greenhouse effect or atmosphere. When we reproduce the calculation, we only get minus 18 degrees Celsius. The exact number does not really matter, and the reason for that deviation would be stuff for another video. But the big question is, where did the 240 watt per square meter come from? Since the IPCC report does not explain in detail how the 240 watt per square meter average radiation power are derived from the solar constant, S0, of 1367 watt per square meter, let's see what other official climate science institutions reveal about the course of the calculation. At John F. B. Michel, Meteorological Office, Bracknell, England, The Greenhouse Effect and Climate Change, we find somewhat more detailed information on the calculation of the temperature of the Earth without atmospheric greenhouse effect. He tells us, the Earth atmosphere system is warmed by short-wave solar radiation at an average rate of S0 times 1 minus alpha over 4, where S0 is the solar constant, alpha is the fraction of radiation reflected from the Earth and atmosphere, and a factor of 1/4 is used to account for the spherical shape of the Earth. With an albedo of alpha of 0.3, we get 239.2 watt per square meter. Since the IPCC report states that the result is approximately 240 watt per square meter, I assume that this is the official method for calculating the greenhouse effect. Now let's recapitulate the calculation in detail. The Earth is hit by solar radiation that passes perpendicularly through a circular area with a radius, r, of the Earth's sphere. This circular area is calculated as A, K equals pi times r square. The solar constant S0 is used to obtain the power radiated onto the Earth. P equals AK times S0 equals pi times r square. Now we correct with the albedo for the reflected power and get the power absorbed by the Earth. P equals 1 minus alpha times pi times r square times S0. This power is absorbed by the entire surface of the Earth, E equals 4 pi r square, and then emitted again as thermal radiation. The Stefan-Boltzmann law then looks like this. Irradiated power equals emitted power. P equals 1 minus alpha times pi times r square times S0 equals 4 pi r square sigma t to the 4th power. Pi times r square truncates out. Resolved after T, we get about 255 Kelvin or minus 18 degrees Celsius as the surface temperature for the Earth without atmosphere or greenhouse effect. With the measured average global temperature of about 15 degrees centigrade, this results in an atmospheric greenhouse effect of approx. 33 degrees centigrade. According to this calculation, the Earth would be about 33 degrees centigrade colder without greenhouse gases than it really is. This is a relatively simple and straightforward calculation, and one wonders why it is not presented to the public by our TV scientist at least once a week, or why it is not of part German physics exams. An attempt to visualize this in a sketch shows how far away this model is from reality. It is hard to believe, but here the Earth is illuminated vertically and uniformly from all directions around the clock with a power of 240 watt per square meter. This is so wrong that nobody dares to present it to the public. Even the most mediocre student would spot the flaws in this calculation. In the next video I will show that IPCC science does not work with this false model out of ignorance. The problem for IPCC science is that in all reasonably realistic models for calculating the average temperature of the Earth without an atmosphere, the greenhouse effect simply disappears.